we have one goal for today. We want to talk about length on polar curves. And you might say, length? We've done that already. We've talked about length for y equals f of x. We've talked about length for x of t, y of t. So now we should be length experts. So our third time, we should be able to do pretty well. Now, how do we do it? Spoiler alert, we go back to things that we've done before. It's a great method in solving problems. Reducing it to something you've done before. Works well in math and works well in life. So, let's begin. So our setting, what do we have? Well, we have a curve in polar coordinates. We'd like to think of our curves as r equals f of theta, where theta runs between some starting and ending angles. Alpha and beta, kind of like A and B, right? Yeah, it is. So what will we do? Well, we say, look, we've done parameterized curves. Let's think of polar curves as parameterized curves where our parameter is the angle. How do we do it? Well, x is r cosine theta, so it means x is f of theta cosine theta. Y is r sine theta, which means f of theta sine theta. All right, now we have our parameterized curve. So length is the integral from alpha to beta, start to finish, the square root of x prime squared plus y prime squared. That's the whole setup. Now, we actually have to go through and fill in the details. What happens? Well, x prime, got to use a product rule, derivative of the first times the second plus the first times the root of the second. Now, derivative of cosine is negative sign. That's why there's a minus sign. Then you have the derivative of y. Derivative of the first times the second plus the first times the derivative of the second. Great. Now, you square that out. And what happens is lots and lots of wonderful things get together. So, for example, you're going to get an f prime of theta squared times cosine squared, and you also get an f prime theta squared times a sine squared. Well, those combine together because cosine squared plus sine squared equals 1, and you're just left with an f prime theta squared. The same thing happens with f of theta squared. F of theta squared sine squared, f of theta squared cosine squared, sine squared cosine squared combine together to give us 1. Beautiful. Now, what about the terms in the middle? Well, you'll notice you get f prime theta, f of theta. Here you get a minus sine theta cosine theta. Here you get a plus sine theta cosine theta. They cancel. And therefore, our formula for finding length for polar curves is beautiful and simple. Integrate, start to finish, square root of the derivative squared plus the function squared. That's it. That's not so bad. Well, of course, doing the integrals might be a little bit challenging, but the setup is wonderful. So now we know how to handle length for parameterized curves. Of course, we should go practice. So let's do some practice involving length. See you soon.